Find the solutions of the equation sine 3x minus 15 degrees equals a half, for which x lies between 0 and 180 degrees. Figure 4. Figure 4 shows part of the curve with equation y equals sine ax minus b. A is bigger than 0, b lies between 0 and pi. The curve cuts the x-axis at the points P, Q and R. Given that the coordinates of P, Q and R are these, respectively, find the values of A and B. So I put all the information in the question here. So we need to find the values of A and B in part 2, but let's do part A first of all. Sine of this is a half. So part 1 then. So let's draw a circle, right cast. Sine 3x minus 15. Let's write it down, the problem. Minus 15 degrees equals 1/2. Okay, let's have a go at it. So let's draw a circle. Right cast. And then sine is positive here and here. X lies between where? 0 and 180. So 3x 0 less than or equal to 3x times by 3 all the way through 540. So we've got solutions here and here in 0 to 360, but we've also got 360 to 540 is here as well. So there's going to be a couple of solutions in here, aren't there? So let's draw two lines. Mark off alpha, the associated acute angle, then simply write sine alpha equals a half. Shift sine then. Shift sine 30, isn't it? Is a half. So alpha is 30 degrees. So our first solution for the 3x minus 15 is equal to, let's put the solution set down, 30. What else? So we'll put a brace here for all the solutions. The next one is around to here, which is 180 minus 30, which is 150. Then we need to go round once more, round 360 and round to here, 390. 390 degrees. I'm going to try and write that properly if I can. And then the next one, I'm round to 360 here, and then so let's go round 360 once, and then round to here, which is 540 back 30, 510. So there's our solution. So let's add 15. So 3x equals, add 15 to all of these then, 45, 165, 405, and 525. And then we can write down what x is. Now divide by, I'll just put it over here, divide by 3 and hope they're all in the range. 15, here 55. If they're not in the range, we'll just take a closer look at the individual example. Here divide by 3, 135, still in the range, isn't it? And this one divide by 3 is 175, which is still in range. So these are the solutions for x. So that's part 1 then. Now we'll do part 2. Let's look at it from the diagram. This is sine ax minus b then, isn't it, here? Okay, sine ax minus b, and we know it goes up and down and up. That's one full period, isn't it? And how long does it take to do that? So from here to here is one period. And that would be pi over 10 to 11 pi over 10 is pi. So the period is 2 pi. The period here is 2 pi over a is the period. Okay, so that equals pi. So that tells us that a is equal to 2. So all we need to move is move the a up, move the pi down, a equals 2 is what we get there. Now, this is pi over 10. It's shifted along by b from here. So if we, now is it plus or minus? If I put b as pi over 10 in here, okay, how much am I shifting it by? I'm shifting it here in this picture, here's our sine 2x as it were, but it's shifted along by pi over 10. So sine 2x is the original graph. And then if I shift it by this much, so a is 2, so if I put b as pi over 10, let's try that. Sine 2x minus pi over 10. Let's just try that. 2x, and have a look at it and see if this fits. I think that's the best way to look at this picture. Okay, so when x is pi over 10, we get 2 pi over 10, which is not going to be right. So this needs to be 2 pi over 10. So when x is pi over 10, we'll get 2 pi over 10, and that's 0. So that's the value then, isn't it? Because we've got the 0 value. So we know that sine 2x, when x is 0, sine 2x is 0, but it's shifted here, and this occurs when x is pi over 10. If we put that in here, we'll get 2 pi over 10 minus 2 pi over 10, which is 0. Sine 0 is 0, and that's where that point is, so it's moved over. So a is 2, and b equals, I'll just put it in here in the diagram, 2 pi over 10, which equals pi over 5.